Kinematics. Mechanics generally classified into two, kinematics and dynamics. Kinematics is the branch of mechanics that study about motion without its cause, whereas dynamics is a branch of mechanics that study about the cause of motion. Here, under this video, we will see about kinematics. To determine kinematics, there are certain physical quantities that describes the motion of an object. Those are displacement, distance, speed, velocity, and acceleration. Under kinematics, these physical quantities are studied: the displacement of an object, the distance covered by an object, the speed, the velocity, and the acceleration of the body will be studied under kinematics. Displacement. Displacement is the shortest path that is drawn from initial point to final point. For example, if is the path that is followed by the moving body, this is the path. An object started from x1 and follows this path and ends its motion at x2. The red one is the path followed by the moving body. The dashed line is the displacement. The displacement is drawn from initial point to final point. The shortest path that is drawn from initial point to final point is displacement, whereas distance is the total journey, the total path covered by the moving body. This is distance. X represents distance. X stands for distance. Change in x is displacement. This is position. Initial position, x1, final position, this is x2. Therefore, change in x, change in displacement is equals to x2 final position minus initial position is equals to displacement, change in displacement. Generally, the difference between distance and displacement is vector quantity that is described by magnitude and direction, but distance is a scalar quantity that is only described by magnitude. The other difference between them is displacement is the shortest path that is drawn from initial point to final point. Distance is the total path covered by the moving body. For example, if I throw this object upward and it returns back to my hand, the displacement of this object is 0 because the object covers certain distance. If it is returns back to this initial point, its displacement is 0, but its distance is twice of the length. And the other difference between distance and the displacement is if this is a circle, an object starts from this point and moving covers certain distance, circumference of the circle, and returns back to this initial point. Its distance is the circumference of the circle, whereas its displacement is 0. This is the difference between distance and displacement. The other point is speed. Speed is a physical quantity used to determine how fast the object is. But velocity is speed plus direction. It is a speed plus direction. The difference between speed and velocity is speed is only expressed by its own magnitude, whereas velocity is expressed both by magnitude and direction. Because of this, velocity is vector, speed is a scalar. Acceleration. Acceleration is the rate of change in velocity. The rate of change in velocity. Let's start from velocity. Velocity. especially instantaneous velocity is expressed as the velocity of an object at a particular time interval. Simply, average velocity is given as V average. Average velocity is equals to change in displacement over change in time. This is the average velocity, the velocity of an object between some interval of time. But instantaneous velocity is different from this. Instantaneous velocity is the velocity of an object at certain particular time. For example, what is the velocity of an object at 2 seconds, at 3 seconds, at a particular time? But this is between certain interval of time. What is the velocity of an object? That is the average velocity. This is the difference between average velocity and instantaneous velocity. Therefore, instantaneous velocity, let's say instantaneous velocity symbolized by V, which is equal to the limit of change in displacement over change in time as change in time goes to zero. As change in time goes to zero. For example, for this type of motion, this is the displacement. The velocity, the instantaneous velocity of this object is equal to the limit of change in displacement over change in time, the time used, the time interval used during this change of position as change of time approach to zero. Change of time approach to zero means the initial value of time is almost very approach to the final value of time. If so, change in time is approach to zero. This means the value of the velocity, that is the instantaneous velocity we are going to determine here, is at a particular time. This means when change of time approach to zero, made equal to zero, initial value of time is equal to final value of time. This means the instantaneous velocity, the velocity determined during this time, is the velocity of an object during particular value of time, So this is equal to the derivative of velocity, the derivative of displacement with respect to time. Let me write here. Look, instantaneous velocity is equal to the limit of change in displacement with respect to time as change in time approach to zero. This is equal to the derivative of displacement with respect to time. When you derive the expression of displacement as a function of time, you have got velocity, instantaneous velocity. The other point is acceleration. Acceleration is the rate of change in velocity. This means acceleration is equals to change in velocity over change in time. This is average acceleration. The acceleration of an object during certain interval of time. This is acceleration. But the acceleration of an object at a particular instant of time is said to be instantaneous acceleration. So, instantaneous acceleration is equal to the derivative of velocity with respect to time. But derivative of velocity is equal to the derivative of displacement with respect to time. Let's substitute derivative of displacement with respect to time instead of velocity. So this is equal to d by dt of dx by dt. So this is equal to d times d square of displacement with respect to dt of square. Acceleration is equals to the derivative of velocity with respect to time, or the double derivation of displacement with respect to time. This expression is equal to this expression. Example is given under this. Example 1. The position of a particle moving along x-axis is given as x of t. Displacement as a function of time is given. Is equal to 7 plus 9t minus twice of t cube. What is it? Is velocity at t is equals to 3 seconds. Time is given in second and the displacement is given in meter. Look, expression of displacement is given. You ask to determine velocity of a particle at a particular instant of time, that is 3 seconds. Because of this question is asking the instantaneous velocity of an object. So, therefore, an instantaneous velocity, first let's find instantaneous velocity as a function of time, because displacement is given as a function of time. Velocity as a function of time is equals to d of x as a function of time, the derivative of x with respect to time. This is equal to d by dt of this expression, because instead of x, substitute this expression, 7 plus 90 minus 2t cube. So this is equal to d by dt of 7 plus d by dt of 90 minus d by dt of 2t cube. Look, the derivative of constant is 0. Constant, any constant number, when it is derivative, it is 0. For example, if this is 100, the derivative of 100 with respect to time is 0. Plus, the derivative of 90 with respect to time is 9. Because when we derivate here, 1 minus 1, t raised to 0, that is 9. Because of this, the derivative of 90 with respect to time is 9 minus 2 is constant, take this to the left, the derivative d by dt of t cube is left. So this is 9 minus the derivative of t cube with respect to time is 2 times 3t cube minus 1. Here t cube, 3 is becomes the coefficient and minus 1. Therefore, this is equal to 9 minus 2 times 3, 6t square. This is velocity as a function of time. 9 minus 6t square. But here, velocity at time t is equals to 3 at a particular time. When time t is 3 seconds, v at 3 seconds is equal to 9 minus 6 times 3 square. 6 times 3 square. This is equal to 9 minus 3 square means 9. 9 times 6, this is 54. So this is equal to minus 45 meter per second. This is time at a particular instantaneous velocity at a particular time. Next, question number 2. A particle's position on x-axis is also given. position is given. Find velocity and B acceleration. X as a function of time is given, which is equal to 4 minus 227t plus t cube. Velocity is required. So to find velocity, v as a function of time is equals to the derivative of displacement with respect to time. This is equal to d by dt of 4 minus 27t plus t cube. This is equal to the derivative of 4, that is constant, 0, minus derivative of 27t, simply that this is 27, plus the derivative of t cube is 3t squared. 3t squared, the same thing within question number 1. Therefore, this is equal to minus 27 plus 3t cube. This is velocity as a function of time. As a function, this is 3t squared. 3t squared. This is velocity as a function of time. Next, acceleration. Acceleration is the derivative of velocity with respect to time, or the double derivative of displacement with respect to time. Is the same thing. B acceleration is equals to the derivative of velocity with respect to time. Here, velocity is obtained, so this is equal to d by dt of this expression minus 27 plus 3t squared. So this is equal to derivative of constant. This is now constant, 0 plus d by dt of 3t squared. So this is equal to 3 is constant, the derivative of 2 t squared times 2t. So this is 6t is left. This is acceleration. Acceleration as a function of time. Generally, kinematics is the branch of mechanics that study about the motion of an object without its cause. Displacement, velocity, acceleration, distance, speed are the physical quantities that are used to describe the motion of an object under kinematics. Displacement, velocity, acceleration, speed, and distance are studied under kinematics. Displacement is the shortest path that is drawn from initial point to final point, whereas distance is the total path covered by the moving body.